Hi, my name is Oleg Šelajev, and you're watching this presentation about Java and Docker and how these two together can create one of the best developer experience for your software development in the industry. I might be a little bit biased. My experience is mostly Java, but I think the modern combination of Java and Docker is a very hard to beat combo. And in the next half an hour, I would like to show you how you can create local development environments using these two, how you can create your test environments for your proper integration tests, and even do some releasing and building some Docker images for your release cycle. Let's get started. Java has historically been a powerhouse in the enterprise, and it's not just because the language is so amazingly great, but mostly because the JVM as a platform is so dynamic. You can create a ton of libraries which can handle absolutely anything that you want, and the ecosystem is brilliant. But also you can create the tools that can be loaded into the JVM, sort of like a sidecar, and transform your application behavior in a very interesting ways. You can inject some telemetry metrics if you want. You can create the tools that will inspect the state of the JVM, like profilers or debuggers. You can create tools and package them as libraries and load them at runtime. This dynamic nature has been like a joker for the JVM because you can be very flexible with what you create. Now, everything in the JVM circle is managed by the JVM and is pretty great if you are a Java developer. You have all the tooling, you can run your Java applications. It's pretty great. It works on all the platforms that you need. Magnificent. But lately, our applications stopped being just Java libraries or even Java applications. They become parts of larger systems where for the normal functionality of the application, we don't just need a Java virtual machine. We need other services that are outside of the control of your JVM. It could be a database, it could be your message broker, it could be your cloud technologies, everything like that. And of course, Java cannot handle that. It cannot manage that conveniently for your development process. You cannot just have your IDE and that become your database or something. So naturally, the solution for that is Docker. Docker is as universally available. It works on all operating systems that you need. So Windows, Linux, Mac OS. It provides you with command line tools and APIs to handle the lifecycle of processes that you would like to run. It can run almost all software imaginable. So the combination of Java and Docker can be used to create an incredibly powerful environments, both for your local development and to support you throughout your software development pipeline. Whether you are doing the whole DevOps methodology or you are more on development side where you just code, test, maybe release your applications, the combination of Java and Docker can help you create an incredible developer experience. Let's take a look. We'll start with code. So here I have, as an example, I have a little Java application, and it's just 2 files, and it's a Quarkus application. Quarkus is a modern application framework for Java. What the application does, it computes some prime numbers. So when we hit it with an HTTP request, it will generate some random bounds for the slice and find all the prime numbers within the slice. So what else it will do? It will also log the metrics, how long the computation has taken, and it will send that data to an external message broker. It will send it to Kafka. Now, what it means that for the runtime of this application, what I need is I need an instance of Kafka running somewhere. Now, to run this application locally, what are my choices? I can use some pre-provisioned managed Kafka instance, maybe from the cloud, maybe from my local development experience and platform teams. I can maybe hack around something with an embedded solution, which won't work for all the technologies, but maybe for some, I could have a reasonably compatible solutions, which is technically a no-go answer. I can also manage the instance of Kafka myself and install it on my machine and then go and install it on my CI workers. And that is clearly a path into nowhere. So I need a containerized instance of Kafka running. So what do? I reach for Docker. Docker would be a great solution here. I can define what services I need to be running. So I can say like, oh, please give me the Zookeeper from the Confluent stack and give me the Kafka from the same Confluent stack. And I can wire them together. I can provide a static configuration where those should be running. I can specify the environment for my Kafka, where it has to be running. And then when I do Docker and Compose up, those services will be running on my machine or wherever the Docker daemon is running. And then I can take that configuration, wire it into my application, and make it use that particular instance of Kafka. There are a lot of manual steps here. It's also very environment specific. You have to not forget to run Docker Compose, and there is a better solution. Let's see what happens if we just run this application. So application framework, the same way it handles the creation of HTTP server or some sort of model marshalling components, what it can also do, it can also use programmatic API to create those environments for me. That feature for Quarkus is called dev services. And what it does, when it finds that my application requires something like Kafka in this instance, and there is no configuration provided where the Kafka is located, what it can do, it can find the Docker environment, and then it can instantiate, pull the container, run the container, and wire the location of that Kafka or that database or that service that you want that it handles for the application, and can wire the application to use that automatically. So now, if I go and check my Docker PS, you can see that the vectorized Red Panda, which is a Kafka implementation by the Red Panda company, is running there. And my application is actually working pretty fine if I run and generate some requests. So if I get my URLs, I will get back some prime numbers, and I will also, my application will send some messages to that Kafka running in my Docker environment. Now, Quarkus is an advanced and very modern framework. It uses Docker Java API to communicate with Docker agent. It uses that via the Testcontainers, which is the libraries to simplify integration testing, and they integrate with Docker and integrate with your programming language. So it uses that for the primitives for managing the containers for you, and it does that. So there is now this project. I don't need to create an environment myself. I can just run my application. I can clone and run it, and it will create the environment for myself. It will do the same for the testing. But if you're not using Quarkus, which has the dev services, or if you're not using Micronaut, which has the test resources implementation of a similar concept, you can very easily use the libraries yourself to create a similar environment. So let me stop this. And then let me quickly just switch to, for example, this application. It's a Spring application, and Spring currently doesn't have this implementation of the dev services components. There's an issue on GitHub that you can check if you want to explore creating those local environments using Docker. But what I can do, I can add the Testcontainers libraries to my ClassPass, and what I can do next, I can just say I can require the particular components to be there for me. So for example, I can say I know that this application requires a relational database. I can say, please give me a new Postgres container, and I can just specify which Docker image name I want. So for example, Postgres, what's the modern? 14 Alpine is pretty modern. And now with this instance, this variable available, I can handle it. I get the lifecycle methods in my API, so I can start, stop. I can also configure both the container to, for example, expose certain ports to my host, or I can override the commands, or I can copy files to the container. I can follow the logs. I have the full programmatic API to manage or configure that container, both the container, and if you use the modules, which are the higher level concepts. So Postgres container is not just like a generic Docker container, but it comes with the information that, we're working with the database. So you can specify, for example, credentials for the database. I don't need to do anything like that. I would just like to start this. So in 2 lines, I can say, when you're starting my application, please start my Postgres as well. And this is a little bit of overkill, of course, because that is too eager. So, but a simple implementation in like 10 lines, what you can do, you can have a conditional that if the configuration where the database is running is not provided, you can create one using the test containers libraries in your Docker environment and wire it back into your application, telling it that, oh, my database is running there and I want you, my application, to use that. So now with this 10 lines of code, what I can do now, I can run my application and we can check there is no Docker running Postgres yet. Okay, there is already. It wasn't before, and now it's ready because it was that fast. My application starts. My application is working now, and this is a sample to do MVC application. Let me very quickly just show you. So if I do localhost 8080, and I will specify the localhost 8080 as the backend for the studio application, we can say hello Docker, be creative. A few to-dos. We can say that this is all running and it's using that database. And you can also see that if I do, let me kill this container, Docker kill. If we remove this Postgres, then suddenly our application will stop responding and it will hang because there is no database, there is no backend. So unfortunately, we cannot even find any to-dos anymore. So it just hangs. It was using that Dockerized Postgres instance that we created right here. So this is how simply in 10 lines of code, even without relying on the framework support, you can create those dynamically loaded and created environments for your applications from your Java application using your Docker environment. And it can be your local Docker desktop installation, or it could be the Docker daemon if you're on Linux, or it can be a remote Docker or anything like that. The configuration is minimal. You add the libraries, you drop in the modules from the test containers environment, and there's a ton of different technologies that we currently have in the test containers ecosystem. So there's almost all popular databases that you can see: MySQL, Oracle, Postgres, Mongo, and so on. And there are other technologies like Kafka and even cloud technologies like LocalStack, which is very, very interesting. Of course, for the local dev environment, this is a nice to have feature, but where it really, really shines is your integration tests. So if we go further through our DevOps pipeline, next we need to test our application. And testing is a little bit special because what we need to do, we need to remember that during the tests, we need to create those environments and run our application in all different edge conditions, very often breaking actually the application or the environment to check the negative conditions. Will my application work when the database is not available? What will happen if my database schema is this way? What if Kafka runs out of topics or any other, edge condition, right? And then that could break the tests. So tests should be isolated, and sometimes they need to have their separate environments, which you can very, very easily do with this similar concept. Let me show you an example. So here's an example of a Spring Boot application. It's a sample application. The logic is not necessary, very important, but what it needs, it requires a database, and it requires Redis, and it requires Kafka for its work. So here I have an abstract integration test example, which creates all of them. It creates a database by overriding the JDBC property, and it uses some lower level test containers primitives to create other containers. So we use the generic container, which is the basic abstraction from the test containers libraries to create Redis. We say that we want to run Redis 6 Alpine, so it will pull it from the Docker Hub, and of course you can pull it from other registries, both internal. If you can do that with the Docker pool, then you can do that and pull the images through test containers libraries. So we configure Redis to expose the port on which is running. We also put it on the network, so you can create custom topologies. And we use the Kafka container component, which is the abstraction that somebody took care and time to write how to run Kafka in a Docker container. So you don't need to provide all that configuration manually in your Docker Compose file or otherwise, but you can just use the abstraction and you get the nice fluent API to create the containers, figure out whether you want zookeepers or not, how to get the syntax of the URLs that you need to connect your application to there. And it's a pretty convenient way to consume those containerized dependencies. Right, so here, what else I can do, even besides just doing the basic information, the basic configuration for my environment. And you can see that actually this tests, I have a little test suite here. You can see that it will run pretty conveniently. What I can also do, I can use my Docker as the environment in which I can inject some chaos engineering practices. So in this example, while the tests are running, we also, besides starting the necessary components like the database or Redis, we're also running the ToxiProxy container. ToxiProxy is a very interesting technology, and what I can use it, I can put it on the same network with some other containers that I have, and then I can inject failures into those networks. So for example, what I could do here, you can see the test passed using my Docker environment created here. My application runs locally, so I can debug it normally. I can I don't know, edit it very, very fast because I don't need to package into Docker to make it run, but it uses those Dockerized dependencies, and the configuration is all dynamic and in the code. So it's very, very convenient. You cannot forget it. Your configuration is standalone. And more importantly, if my tests require like separate configurations for some good use cases and some maybe naughty use cases, then I can just have separate classes and programmatically create more environments like this. So back to the ToxiProxy. What I can do, I can say that, oh, what will happen if I would proxy my connection to Redis? I will proxy my connection to Redis via the ToxiProxy, and I will configure my application to go through this proxy instead of directly to Redis. And then I can inject, for example, latency of 2 seconds for every interaction with my Redis. Let's take the most complex test, and we can see whether it will run or not. So currently it runs in under 3 seconds. Now, if we inject the latency, I expect it to run for at least around 10 seconds, because I know that test goes to Redis and sends the request to my application fairly often, more than once. So the test will run, and you can see that it does pass and at least progresses, but it is much, much slower. And if I inject even more latency, for example, 6 seconds, I think this test is supposed to fail with the timeouts. So you can use your Docker environment to create those more complex topologies of the containers and run some chaos engineering practices. And if you wish so, you can create the abstractions that will use that. So you can create, for example, a class that will combine your Redis and your ToxiProxy and act as a Redis container, but under the hood, it will use the proxy and it will inject those network failures randomly. You can see the test fails with the timeouts if I have 6 seconds latency on the request, which is unfortunate, but it's very, very good because you can trust those tests now, and you know that your application cannot survive when Redis is not available for 5 seconds. And it's not just the normal databases that you can put in a Docker container. You can put any kind of technologies. For example, I can, where's my, here. For example, there's a technology called local stack, which I can run in my Docker container. And there is a local stack Testcontainers module for your convenience. So what I can do, what it is, it's a fully functional AWS stack that you can run in your local Docker environment. That means that if your application needs some sort of cloud technologies from AWS, for example, S3 or, I don't know, Dynamo or Lambda, You can run those, you can enable those, you can configure your application to use those particular endpoints, and then you can run it. And then, for example, you can use the normal API. You can execute commands in the containers as you would do with Docker exec to pre-provision your cloud stack state, and then you can use it. So can I have a local AWS in my Docker? The answer is yes. And with using test containers, I can also not bother with manually pulling any images, and it can also have the programmatic access to its all configuration. This would work for your integration tests. That will work with your for your local environment creation. You can manage the life cycle of those items. Yeah, you can start, stop the containers. You can also specify that you might want your containers to outlive your test executions if you want to have a truly singleton sort of container running in the background, and then your application reconnect to that again and again. So all those API are available, and you can run even the complex examples for very modern applications that you need. And it's not just the particular clouds as well. You can just, if you want, you can just run. Wait, let's wait for the thing to finish. It is starting. It is now starting our Spring application. So I assume that our test will be very, very quickly green. So we created AWS, we created some buckets, we put some files into S3, and we took the files back. And this is, of course, directly interacting with S3, but you can use your application functionality to do that, and you can have your complex tests or use that local Dockerized local stack to as your local development environment while you're developing the application. So this was an example of AWS that you can run in with local stack fully in your Docker environment. And another example that I would like to show you is that you can have a full-blown Kubernetes implementation running in your Docker environment used for your tests. So here what we're using the K3s module from the test containers ecosystem, and we're going to create the Kubernetes cluster. We're going to start it, and we're going to take the config, pass it into the Kubernetes client, and then we're going to create the namespaces, or you can do any operation that you want if you're developing operators or anything like that. So I can run this test, and it will pull the images for the Rancher K3s implementation, and it will run the test and will create the namespaces for me. It will take a second to start it up, but it will successfully, hopefully, create a cluster and run this for me. And you can have, if you do operator development for Kubernetes, you can use this. You can also use other modules from the test containers ecosystem, for example, to create just the API server, not the full-blown Kubernetes cluster, and run the test against that if that is sufficient for your needs. So the test passes, we have created the cluster, we have created a namespace in it, and we successfully queried that from the cluster. And the last part that I want to talk about is the release. So normally you will run your Java application and then you will package it, and then historically it was jar files, but nowadays obviously nobody does jar files. What we do is we do either Docker containers or OCI containers. So there are a few options how you can do this. You can run your Docker, write to Docker files and maintain those, and then run and build your application. And then they will specify exactly what needs to be in your Docker image and how to run that. You can have multiple flavors of those. Some of them are simpler, some of them are more complex. Some Java applications you can run in ahead of time compiled mode where it's just a binary. So your Docker file could be very, very simple. So you can have the minimal base image and then just a minimal configuration. But this is still something that you need to maintain. Another option that I would like to highlight how you can use Java or how you can use Docker for your Java applications is to use by using build packs. Build packs is a CNCF project that is sort of they're the builders for your application. So you run the command line application on your source, and it will look at the source. It will find out what it is. In this case, it's a Java application, and it will use Docker daemon to build your application. And so it takes the source on as an input, and the output is the container definition. And of course, besides just using that manually on the command line, what you can do, you have the API, Java API, because everything in Java is a library, or can be a library. Right, recent project, build packs, examples. Here, what I can have, I can say, oh, give me what is my Docker client. So because I don't want to use my Docker manually, I don't have to use my Docker manually from the command line. I can just run it programmatically. And then what I can say, please build me, here's my build pack. This is my Docker. This is my application. This is my configuration for the build pack. Build. And what it will build me a final image called test spring application. And then I can run tests against that particular image within the same build process, verifying that it actually completed normally. So I will say that I want my container by the name that I just created, and I will want to expose the port where the application is supposed to be running. I will start my application, and then I will use the high-level functional tests saying that, oh, I want to open port 8080, or whatever the mapped port is on my host side for that. I want to get the greetings, and then I want to assert that this actually returns hello world. So what this means that I can run this test, and it will build me the container called test spring application using the build pack within my Docker environment. Isn't this great? I think it's pretty great. So I think this will take a moment, but it shouldn't be that bad. Building the images is a heavy process, so we'll see how it rolls. So while we're waiting for this, let's summarize. We looked at how you can use Docker while developing Java applications, while running your integration tests, how you can create those ephemeral environments using test containers in your Docker to have all the real dependencies, service dependencies your application needs, how you can wire that back into your Java application configuration, and how you can create complex environments, not just with the technologies like databases or message brokers, but also with the with local stack, which is the AWS implementation, or you can run your Kubernetes cluster in your Docker environment, which we saw in that one test that we run. And besides that, you don't only have the option to run and use those applications, use those external dependencies and run them within the Docker, but you can also use your Docker environment to build the final container images of your application if you wish. You have the flexible API to do so, and it can run, and then you can compile together in one test or in one program the building phase for your application and actually testing that build has succeeded. You would probably do this at the end of your application lifecycle. If we're talking about Spring, this is also a convenient way to test maybe that your application works in ahead of time compiled native image mode, where you can use a different build pack, build pack configuration where you say that you want the native packaging, and you see here you don't specify the actual final Docker image, but the build packs builder knows the current state, and depending on the builder, you can specify how to build your applications in a generic way. So however many microservices using Spring you have, that you can build them all into the container images at the end using the same repeatable process, whether this is your Java mode, native image mode, or anything like that. So this is mostly what I wanted to show you. If you are interested in test containers or how to use test containers API to create those ephemeral environments, please check out the resources. But I hope that in the last minutes, I showed you how you can use Docker to supercharge your development experience throughout your DevOps phases for your Java applications. Thank you.